As you can see, schematic manager, and in this I already created one program here. Okay, so this programming, PLC programming, we'll see after completing our SCADA. Okay, how to do this programming and all. So for this, you can see I have mentioned some logic here. I address I0.0 for start command from push button. I0.1 for stop command from push button. Okay, so here we are using NONC for start stop. Similarly, we are having motor. For motor, I am using the output address Q0.0 here also. Okay, this is called latching. So I'm using the same address here. Latching means holding the output. So if you are using a push button, okay, push button means momentary switch. That means when you press the button, it is on, and when you release the button, it goes off. Right. So when I press and release the button, push button, okay, your output should remain on. Your output should continuously remain on. Okay. 1 second. Huh? Hello. Okay, I think your device is having some problem. Here is not showing your microphone or something. Bluetooth. Okay, maybe some mic problem in that, I think. Okay, in your device there might be some problem, I think. Okay, you can you keep it continuous like this only call? You can keep this call continuous. Okay, so I just you can keep it this as it is. Okay. Now, can you hear me now? Okay. Now, so here I made one predefined program here in PLC. Okay. As there should be a program present in PLC. So I'm using another address here. You can see DB address. DB means it's called data block address in Siemens. So it's additional memory blocks, okay, which is an internal memory for storing temporary information, temporary data in your PLC. Okay, so whereas I and these Q addresses are used to link with your physical addresses. Means physical addresses means your hardware inputs and outputs. Okay, so this I and Q addresses are for inputs and Q for outputs. Okay, they are linked with the input output addresses. But if I need to store some temporary values or status, okay, because we are having digital as well as analog values, okay, to store this information we need some additional memory. So that is your DB memory. Okay, so mostly in industry they are using DB addressing for SCADA communication. Okay, so here we are using DB address for start and stop command. Okay, you can see the address db1.dbx0.0. Okay, this format we'll see when we do the PLC. Now, here you can see we are having, I'm giving some text also. Start motor from SCADA. Similarly, stop motor from SCADA for these two commands. Okay. Now, so here I have written a program for this. Okay. Now, this addressing we need to link with our SCADA. Okay, so why we are using this means, see, I address is your hardware address. Okay, hardware switch. So that hardware switch means until you operate the switch, it will not operate. Right, it will not become on. So if I use SCADA is a graphics. Okay, graphics means that is a software, is a graphics that is in our monitor. So when I press that button on monitor here, so that switch will operate automatically. No, not possible, right? So until that switch is operated, your input will not become on. So to bypass that input address, we are using internal memory of your PLC. Okay, so for such purpose, we are using DB address. Okay, so we are bypassing this I addresses for start and stop from SCADA. Okay, now, so here I have made one program here. Okay, so let's see how to connect this addressing with the SCADA. Okay. I'll send you this recording also, this configuration recording for semantic manager also. Okay, later. Now here you can see we are having SCADA software, that is semantic WINCC Explorer. Okay, so here semantic WINCC Explorer is having three options. Okay, when you create the project. Okay, 1 second. So here you can double click open the semantic manager. Okay, sorry, semantic WinCC Explorer. So WinCC stands for Windows Control Center. WinCC stands for Windows Control Center. Okay, so here we are having many different companies, brands which are having their own softwares. Okay, so this WinCC is a Siemens brand. Okay, so here we can directly link this SCADA with our Siemens PLC. Okay, so no means internal driver is already provided here for that communication. Okay, so just you need to add up that driver. Okay, so I'll show you how to configure this. Okay, so it takes some time to start. Some time. So as you can see, there is one project is there. So I want to close this project. This is a older one, and I create a new one. So go to File, click on Close. It will close this project. Now I want to create a new project. So here go to File, New. Now, so when I create a new project, you can see single user project, multi-user project, and client project. So there are three options here. So single user project means if I want a single server. Single server means a server which is directly connected to your PLC. Okay, and this PC, okay, which is sorry, a server which is a PC, okay, which is directly connected to PLC. Okay, so here we are having options like multiple user. Okay, multi-user means I want to use multiple servers. If I am having a very big plant, okay, large number of IOs, thousands of IOs, it will be difficult to monitor in SCADA. Okay, with one single PC. Okay, I cannot depend on a single PC. So we'll be adding up to 12 servers here. Okay, we are having 12 servers option here. Okay, that's called multi-user project. And another option is client project. So here from your main server, okay, these servers are directly connected to your PLC. Okay, but I want to share information from that main server to different PCs, to different people, okay, or persons. I just want to share the information. Okay, so those PCs will be known as client project. Okay, they are known as clients. Okay, so you can add up to 32 clients here. Means 32 members can monitor with one single server. okay, or 32 clients for multi-user project also. Even if you are having 12 servers, you can have only 32 clients, okay, on a single network. Okay, this is about only a single network. Single network means if you are having a switch hub, okay, LAN network, okay, on that a single network, okay. And apart from this, you can have web clients also. Web means on internet. On internet also you can configure many clients, okay, up to 1000 clients also you can add up, okay. Means at different locations like Mumbai, Delhi, Kolkata, like that we are having different locations, okay. For there, or from there also you want to monitor, then you need to go for this multi-user project, okay. As we are doing a basic one, so we are going with a single user project, okay. If any existing projects are there, you can open from this folder, okay. Now say click OK here. Here it is asking for the name, okay, project name. So I can give some name like I am giving today's date to remember, to 2022, okay. Create. So it takes some time to create your project. Okay. So here you can see at top, it is showing you C colon slash users. This is a location where your project is created, and your project name dot mcp file is there. Okay, this is a one extension format for mcp. Okay, for your project. Okay, with this file you can open your project directly also. Okay, now here in this project created, we are having different options here. Okay, yesterday we discussed about tag management, graphics designer, okay, alarm, tag logging, report, okay. So you'll see these things, okay, one by one. Now, so double click open tag management first, because we need to create tags here, okay. We are connecting with the PLC, okay. So double click open tag management. It opens a new window with the name tag management again, okay, WINCC configuration studio. Okay, so here you can see in tag management we are already having internal tags. So when you select this internal tags, at right side you can see it is having predefined tags here, okay, current user. These are used for different applications, okay, for redundant server status, etc. Okay, so no need to touch these tags, so these are predefined by the Siemens people only. At right side we are having in detail properties for those particular tags. Okay, these are all memory internal tags. Okay, now we need to add one driver here to connect with the external tag. So right click on this, go to add new driver. Here we are having semantic S7 protocol suite, okay, and below you can see we are having semantic S7 1200 1500 channels also. Means we are having TIA portal software, new software. With that also you can link with 1200 and 1500 PLCs. Okay, apart from that, any other third party modules are there, Modbus, Mitsubishi, Allen Bradley, okay. With these systems also you can add. So select semantic S7 protocol suite, okay, for our protocol which we are using. Now in this you can see different protocol types are there, MPI, Profibus, okay, industrial Ethernet, TCP IP. So here how do you identify which protocol we are using? As we can see, we are using a simulation software for running the PLC program. It's called PLC sim, okay. As we are not having hardware with us, so I am using a simulator, okay, which is software here to run the program. You can see what protocol is there, TCP IP, okay. So we have to select this TCP IP here. So right click on TCP IP. First go to the system parameters to select that driver for this. So in this, go to the unit, In this we are having logical device name. So here we are having different protocols again, drivers. So out of this select PLC SIM TCP IP. If we are having hardware, then we have to select with your hardware protocol name. Like I'm having Qualcomm Atheros Ethernet port on my laptop. Okay, so that's what is showing Qualcomm. Whereas in other PLCs it might be Realtek, Atheros only. Okay, or gateway. Different protocols are there. Okay, that driver you need to select. So I select this PLC SIM TCP IP. Say okay. Now again right click on TCP IP here. New connection. Here we have to create one new connection. Okay, driver connection name. Okay, so just like I'm connecting with the PLC, so I'll give the name like PLC 1. Okay, now again right click on PLC 1, go to the connection parameters. Here in this connection parameter, okay, we need to set the IP address. Because we are using Ethernet protocol, we need to use IP address here. Okay, 192.168.0.1. This is the IP address of your PLC. Okay, that you can check with the PLC hardware configuration in the software. Okay, then your PLC is connected in slot number 2 always. Okay, so I am setting here 2 directly. Okay, then say okay. Now with this driver, you can see at the right side we are having tags option. Tags. Okay, in this we have to create our tag names. We are having tags, data type. Okay, connection and address. Okay, these are the things we need to configure. So just like I give the tag name like start, data type, your start is a push button, means on off button, right? So it's a digital. Digital means also known as binary. So you select it as a binary tag. Then for address, you have to search here. You can see DB, data area is DB, or if it is bit memory, it's another memory type is there, M address. Okay, or I address or Q address. Okay, so we have to use this DB. DB number 1, in that we are having byte number and bit number 0. Okay, say okay. So this address is added here. Similarly, I create a stop. Is also a binary tag. Browse for the address here. Just change the bit number to 1. Okay, this address is bit number 0 and 1. You can see here in the program. Bit number 0 and 1 is there. Okay, then motor. So here Q0.0 is the output address. Okay, so I created 3 tags here: start, stop and motor. Okay, for digital operation. I minimize this now. No need to save. Here it is a auto save for tag management, tag listing. Next we go for the designing. For that go to the graphics designer. So right click on graphics designer, select new picture. So this picture is added here, okay, in the right window. So here you can see new PDL0.pdl. PDL stands for, it's an extension format for the picture. PDL stands for picture design language. Okay, so here I can change the name here, like I will give the name like motor. So it is saved as a motor.pdl. Now double click open this picture. So it is opening graphics designer window here. So here you will get tips and tricks also. So you can simply remove this. Now, so here this is your designer window. Okay, in this window you can see we are having this grid. Okay, dots, or if you don't want the dots, here we are having grid on or off option. Grid means just like if you want to select some size or set some object on that particular area location. Okay, you can select this grid. Okay, now at right side you can see we are having some standard window. Here we are having some drawing tools like from standard objects, line. Okay, you can drag this, select and drag it here. Okay, you cannot double click, just select and drag to select the shapes. Okay, you can create different shapes here. Similarly, ellipse, circle, okay, different objects you can draw here. So for example, I want to create my own object. For that I'll go with the circle, like a pump symbol or a motor symbol. Okay, I take a circle, and for base, for a pump, I'll go with the polygon. Click here once, then drag it, select here at the left corner and then at the right side. Okay, now I want to bring this object. Okay, I'm keeping this object one on the other. If I want to bring the back object to the front, select this. So here we are having research. Yeah. Here you can see we are having move to front option. Okay, when you click on this object, move to front option. Okay, move to front, you get this circle at the front, and you can set this also. Then for a pump symbol, I'll take one rectangle for nose, and I want to move to the back like this. Now here I have taken three different objects, one circle, one rectangle and one polygon. So what I do, I select all, right click on this, we are having group option, group, click on group. Now this becomes one single object. So like this you can create your own objects also. Okay, now for operating this motor, okay, I will use it as a motor. To operate this output, okay, I need a push button. Okay, so for that you can close this standard object, close smart object folder. In Windows objects you can see we are having button symbol. Select the button and move the cursor here and drag it. So when you leave this, it shows you the button configuration window. In this you can change the text on the button, like I give start, say okay. Similarly, I select one more button, select the button once again and just drag it over here. So I give the name stop. Now for I'm just giving the text here. Okay, so here we have created the tags. So those tag names, okay, we have to assign to these buttons. So select the start button. So as we are operating this, means we are pressing the button. Okay, so then there should be some action. So for this you can see at the bottom it is showing object properties, tags. Okay, different options are available here. So in this, select the start button. At bottom, go to object properties. In this we are having properties and events. So for operating the button we need to select events because we have to operate the output. Okay, this button. Okay, now so in events we are having mouse action. Mouse means our keypad mouse or general mouse we use, right? Right click and left click. So when you click any mouse click, so one action you can select for that, right click or left click. So here you can see press left. When you are pressing, I want some action, and when you are releasing, for that also I want to make some action. I want to do some graphic. Okay, I want to display something. Okay, similarly for press right and release right. Okay, so I'll go with the press left because usually we use a left click, right? So I right click on this. Here we are having direct connection. Select the direct connection. In this direct connection, we are having two options again, source and target. So source means it can be any constant or any property or any tag. Okay, some status. Okay, so I select constant here. Constant means some value, some text. Okay, that also you can use. So the value 1. So when I press start, the value 1 should go to the target. Target is our tag, where it should go, right? It should go to the target, that is our tag. In this, you need to browse using this by clicking on this yellow box. In this, you can see list of all tags. If it is not displayed anything here, just check here in the data source if it is tick marked or not. Okay. When you select that, it will show you the list of all tags. In this, you can see we are having start tag. Select start tag. Say okay. Okay. Now, so this is for pressing. So when it's a push button, right? So when you press, it should be 1. And when you release, it should become 0 again. So I go for the release left also. Direct connection, constant, 0. For the same tag start, right? It should become 1 and 0 again for a push button. Similarly for stop, here also the same thing. When you press 1, so I will select constant as 1 in this tag, in our stop tag. Say okay. Similarly for release left, direct connection, 0, tag to stop. Now next is to display our output. Okay, so for output, how we will display? We change the color. Okay, we change the color of the output. When the output is on or off, it should change the color. So for this, select the object here, then go to the properties. In this properties, you can see we are having different options here. Group, in this geometry, colors, style. Okay, in colors you can change the background color. Okay, so whenever you take any object from this standard objects for making any new object, so you need to always disable one option here called global color scheme, which is available in the effects option. You need to disable this. Okay, so I just like I'm having 3 different objects. So you can see where it is showing rectangle, polygon, as well as a circle at the bottom here. Okay, suppose I want to change color only in the circle. Okay, I will go to the circle, go to the effects first. For this global color scheme, disable it. You can see when I double click here, it is converted to no. Means you can see here it is change the color here. Static and dynamic. Static means no change. Okay, if you don't want to make any changes or color change anything, so you can select the static option here. Otherwise, if you want to make it dynamic, you have to select dynamic here. Okay, but we don't want to change the global color. We want to change the color of that object. So go to the circle, colors. In this, go to the background color, dynamic. Okay, this is your static color. You can see same color is there, the static, but we want to make it dynamic. So right click on this, go to dynamic dialog. Here in this, we have to add our output tag. So the data type is boolean, which is digital, right? So background color here, double click for true. We need some green color. For false, you can select red color. And for which tag, for which output you should run, you select the tag from here, tag motor. Say okay. That's it. You can check if any error, no errors occurred, close. then say okay. You can see the status of this dynamic symbol is also changed. If this symbol is there, that means you are given the tag for this. Now I save this project, save this window, then check for the runtime. You can see runtime button is also there. Okay, like a play button. Click on this. It activates your runtime window. So here you can see. Second. Here you can see we're having this runtime window opened here, and we're having one simulator to open on the. So instead of using hardware input and output, I'm using this simulator. When I click this address here, okay, I byte number 0, in that we are having bit number 0. So output is on here, right? Here you can see in the SCADA it is showing green. Okay, sorry. The output is on. Here logic also on. When I give stop here, press and release. Okay, now I want to operate from SCADA. So when I click on start button here, you can see output is on. And when I press on stop, you can see there. Okay, in the logic also it is showing stop, and C is going off. This color is changing. Okay, you see when I press again, you can see in the logic also DB address at the bottom, it is going green. When I release, it is going off. Okay, so this way we are communicating PLC and SCADA and controlling the process. Okay, so any doubt here? Anyone? Yes, understood here how to connect with the SCADA. Yes, any doubt?
Sir,